Good afternoon, everybody. Welcome back to lecture number 32. Today we had a question that the answer of it in constant power k theta is variable. So in constant power, which is what we call the field weakening, and the key feature, its speed is above omega rated. It's a very important question. Okay. And K flux could be K flux as a function of voltage times seconds over radians or voltage over RPM, but it is the product of K times phi. Also, we can say it is K, another constant, times F. So because here IF is fixed, the constant, the motor constant is constant. Here, because it's field weakening, what will happen? It drops. Okay? It's important to understand these questions. So last time we talked about the power electronics, okay? So what did we say about the power electronics? You either have AC and you get DC, and this DC you control it by the firing angle. If the firing angle is positive, is less than 90 degrees, what will happen? We will enter the motoring mode. If the firing angle is above 90 degrees, what will happen? We will go to the regenerative or regenerator mode. We'll talk about it today, inshallah. So, mark yourself as late, please. What's next is the examples that we solve. So the first example, I think we tried to solve it, but I'm going to show you the example. We are really late. So this example, it's separately excited, controlled by single phase. This is single phase, so VT would be V phase, which is 265. This is single phase RMS. It's not line to line. Times cosine alpha times this constant, 2 square root of 2 over pi. Now, at 30 degrees, you calculate VT to be 206. Then you get here at the speed of the motor is EA over the constant, 0.18 V over RPM. Note that here we get the speed in RPM because of what? Because the constant is what? Is V over RPM. If the constant was V second over radians, you have to convert, you will get your speed in omega. Okay? It's very important. Now, part B of the question, find the torque. What's the torque? It's the constant times IA. So, you have to convert the constant from V over RPM to voltage seconds over radians, because الفورمولا حقت التورك ما تضبط إلا مع الكونستنت لما يصير في voltage times seconds over radians. وقلنا في الكلاس عشان نتجنب هذه المشاكل, it's better to always convert it to voltage seconds over radians. The last part of the question was calculate the power, the input power, electric power of the motor. Forget about this formula, it's VTIA, because this is a series motor. Is this a series motor? No, separately excited. So it's VTIA, and VT is 206 times IA is 40, so the input power is 8.2 kilowatts. The other example is separately excited, but now it's controlled by what? Three-phase converter. The converter is operated from 480. So is 480 line to line?
Line to line.
It is line to line, because in three-phase we love line to line, which is also RMS. In single phase we do not have line to line. So here, that's the first step, divide by square root of 3. Then get VT, where you plug 277, not 480. Then you get VT equal to 648 cosine alpha. So that's the effective DC from the power converter. This is the equation if it's three-phase. These two equations are important. even in real life, they are used. If you buy a DC motor from Siemens, they will provide it in the manual, provide these two equations if you're connecting it to three-phase or single-phase. And nowadays, the power electronics are baked inside the DC motor. No need to have a separate device. The question is, so he gave you the parameter, he gave you K flux in voltage over RPM. He said find the no load speed at firing angle alpha 0, alpha 30. Assume at no load, so at no load IA is small, which refers to rotational losses. He said at no load the IA is 10% of the rated current. What's the rated current? 165. So what's 10%? 16.5. That's why we have here EA equal VT minus 16.5 times RA, then you get the 646.6. You plug, of course, VT one time at cosine 0, one time at cosine 30. Okay? So if you do it for the no-load speed, again we're using EA over the constant that has a unit of V over RPM. It's 646 over 0.3, which is 1959 RPM. What will happen if you increase the firing angle? Effective VT will be what? Will be smaller. Now it's 561. The cosine and maximum at 0. So if you make it 30, your cosine is going to be smaller. So your VT is going to be what? Smaller. So EA will be what? It was EA 646, now it's 559. It is smaller. If the EA is smaller, the speed is smaller. So what do we understand? For firing angle from 0 to 30, the speed will drop. And this is how we control DC motor from an AC power supply. Remember, there is a box between the supply and the motor, which is the DC to AC, no, AC to DC converter. Okay? The last part is find the firing angle to obtain the rated speed of 18,000 RPM at rated motor current. Reverse engineering. We need to start with the speed, get the corresponding what? EA. So let's do it. We got the corresponding EA to be the constant in RPM, 0.33 times 1800 RPM. That's 594. Then VT is the supply which happens to be in this equation. So we need to find VT. What is the corresponding VT? And then we solve 648 times cosine alpha equal to that VT that we calculated. And then we can get alpha by taking cosine inverse. So this is a little bit math involved. So I'm going to make the bonus 0.2, okay? Those who did to be consistent with these two bonuses. في أحد عنده bonus غيره? I think I wrote your bonus on the quiz.
Yes.
صح أحمد? So we have two bonuses, this bonus 1 and bonus activity 2. This bonus will be added towards your class work. It's real 0.2. Remember, sometimes you say بقى لي درجة على A+, بقى لي درجة this is all كله بعد الدف وبعد. Okay? It's not a valid argument. Let's solve this problem. So what is EA? So for 1800 RPM, EA equals K flux, this has a unit of in RPM, times N. So 0.33 times 1800, what is the EA? I think 600? 594. Now, what is VT equal EA plus IARA, 36. This is separately excited. So VT will be 594 plus 165 times the RA, which is 0.0874. Then you will get the corresponding 608.4. So now, the AC has VP equal to what? 480 over square root of 3, which is 277. Vt equals, what's the constant? 648, which is 3 times square root of 6 times 277 over pi, which is 648 cosine alpha. You want this to be what? 608. So alpha is cosine inverse 608.4, 648, and you will get the corresponding in the value in degrees to be 20.1. It's not 0, it's not 30, it's between. Let me ask you a question. Part A and part B. What is the mechanical difference between part A problem and part B? Speed. Yes, but why the speed in part A is different than? No. The difference is in the question itself. In the question, in part A, it is no load. There is no load connected. In part B, we connected a mechanical load. So this mechanical load will have, rated current. Yeah, for rated, it will draw a rated current. So both speeds, well, here's the trick. At 0 degrees, the speed is 1959. If you change no load speed at a different firing angle is 1696. But now you connect a load and you adjust the alpha to be faster than the no load at the alpha 30. So alpha, if you change the alpha and you add a load, you have different combination. So now you have full speed control using the power electronics. واضحة؟ لما ما يصير ما في load, if you change alpha, you will change the speed. And it varies. We tried 1960, we tried 1600, 1700 RPM. Now I connected the load, full load. إذا سويت mechanical load connected a DC motor, it will draw more current, صح? Because it draws more current, depending on my alpha, I can adjust the loaded motor speed. Before in E360, لما كنا مبتدئين في الماشينز ما نتدخل في السورس خلاص في لود ما في لود خلاص 2 operating points. لا, with the power electronics we have AC. Because we have AC, we adjust the speed using the firing angle of the thyristor control حق الconverter. We can have wider speed of loaded and not loaded speeds. So if you buy a DC motor, you want to control its speed, what's the smartest way? Buy a power converter. So that's why they say power inverters solve all the problems of electric motors. And without power electronics, electric machines will be the 1980s, 1960s machines. Okay? The last question is the speed of separately excited DC motor is controlled by a DC chopper. What did I say about chopper? From its name, chopper means it cuts the effective DC value. Chopper was what?
Cuts the effective DC.
Cuts the effective DC value. So let's say we connected here DC supply of 120 volt. These are the machine specification, and again it's in voltage over RPM. This is separate. This is separately excited. So in all three cases we have separately excited. The question says the motor drives a constant torque. Constant torque. So what does it mean, constant torque? It means this constant Ka flux is constant. So this is constant torque. And also it means we cannot exceed omega base. What is omega base here? Did he tell you?
No.
He didn't tell us. So you have to find it. But what's the trick? He said assume the motor current is constant, find the speed, the range of speeds. Basically he's asking you to find those axes. Of course, what's the minimum speed of a DC motor?
0.
0. minimum speed is 0. This corresponds to EA to be what?
0.
0. However, this motor, he is telling you the motor drives constant torque load requiring an average armature current of 20 amps. So even at no load, to keep the motor spinning, EA is 0. This is separately excited. We'll try to, most probably the exam problems will be maybe 2 AC, 2 DC problems, simple problems from the examples. I don't have time to come up with new questions. Okay, so study those 18 examples. Maybe we'll do some small tricks. So the separately excited means the field here. So at no load, the motor will spin, but we all know EA is what? K flux times omega at no load. Omega n. So if omega is 0, EA is what?
0.
0. Does this mean that there is no current is flowing? Does it mean VT is 0? No. It means because there is rotational losses, VT equal IA RA. So what is VT? He didn't tell you even the supply. No, he told you the supply, it's 120 volt. So the question is, for omega speed is 0, we have EA is 0. From this equation, which is EA equal VT minus IA RA, because EA is 0, VT has to equal to IA RA. But IA is fixed in the question. Across this region, IA is always has average value of 20 amps. So this means VT would equal to 20 times 0.5, which is 10 volts. Remember, now we, in this region, to do constant torque, what is the requirement? Change the voltage. So if I want to draw the voltage, let me use another color. If I want to draw the voltage, we will start with what? 10 volts. And we keep increasing. Okay? Until I reach here, where I have to arrive to what? V rated. So I need to start from 10 to 250 in order to satisfy constant torque. This is only for constant torque. If I have fan, is this applicable?
No.
No, because fan, that is not a constant torque. This is only for constant torque. If I want to fix the torque, I need to reduce the voltage at low speed, keep increasing. So what is the value of alpha for the chopper? Alpha is T on over, alpha is what? Is 10% of the supply. No, it's 10. Is it 10 or 12? It says 1 over 12. So because VT equal to 10 volts, alpha equal to 10 over 120, which is 1 over 12. This is the minimum. For the maximum speed corresponds to V rated. What is V rated?
120.
Here I reach for the constant torque. Remember, this is another curve. This is the y-axis هو volts. Here I have 10, here I have 20. So this is the curve of the voltage across the speed. So at maximum, I need to design my voltage range to be from 10 to 110. So what is EA at omega no rated, it's not no load. He didn't say it's loaded or not. Control the DC supply, the armature. The motor already derived a constant torque load. So it is not no load, it is load. This is omega M. This is omega M. So at omega M rated, which we don't know, I need to get EA to be what? 120 minus
20.
20 times 0.5, which is 10. So it's 110 volts. So I can get omega rated to be what? 110 over the constant, 0.05. What's the speed? Is the constant in V over, it's in V over RPM. So that's N. Right. What's the speed?
2200.
2.2 kilo RPM. It's fine. Okay? So what's the speed here? The range from 0 to 2200 RPM. It doesn't matter. Convert it to radians. Times 2 pi over 6. So that's the range of your speed control until rated speed. This is only for the constant torque. What will happen if I want for that constant torque? If I want to exceed that speed, what will happen? I have to change the field, and I will no longer have the same torque. I need to drop my torque. I need to what? Drop my torque. So what's the range of alpha? From 0, from 1 over 12 to 1. From 1 over 12 at speed 0, 1 at speed 2.2 thousand RPM. Okay. Now, is it clear? Any question about today's examples? Now let's jump to, we finished motor control, and you as an engineer, if I ask you the question, we love traditional control, power electronics based control, or what? Power electronics, because you see, in power electronics you can control alpha, you don't have to wait for the load, you can change the voltage, and the thing is you don't need a DC supply. Having industrials DC supplies is not practical. And that's why many DC motors, they run directly on the wall, because they have the converter inside. And in your senior project, Sam, and you're still not doing it. When you have your senior project and you buy a DC motor, no need to buy a battery. Because you know you're going to buy a single phase converter. Right? Usually it comes with it. What happened to your motor? The one you bought? Why? Because of the... طيب, you don't have any motor now?
لا في عندي
That push.
دينامو بالسيارة
What's that machine?
سينكرونس
Synchronous. And is it working?
إن شاء الله.
So, any other machine is used in the senior project?
We will use one for the water project.
Pump is easy, you can buy. Pump is usually induction, صح?
I think yes. Small.
Induction. So let me ask you one more question. Let me ask you one more question. Let's say we are finishing the controlling. Do you remember they told you when you start a motor from scratch, DC motor, we will have the issue of very high current?
Yes.
And what's the solution we just made?
Gradual voltage.
Reduce the voltage using power electronics. So the issue here is, I'm not going to cover it much, but DC motor starter, the inrush current is very high unless you reduce the supply. If you cannot reduce the supply, there is another way. So DC starter using two methods: reduce VT, power electronics, or add resistance, AE. So for separately excited motor, for example, we insert external resistance at start, or you reduce the voltage like what we did in the previous example. So we already showed example 9. Here what example? 9. Here I'm not going to do example, but if you increase the current, if you don't have power electronics, you can add a resistance. And here we have something called, I want you to know the name, we call the 5-point starter. What's the idea of the 5-point starter? The idea of the 5-point starter is you have solenoids connected to the machine, and gradually, the more it draws current, the solenoid would drive here at point 1, so the resistance is at the maximum. Gradually, it will go to point 2, point 3, point 4, point 5. Due to this solenoid, the electromagnet, that will keep drawing this until it reaches the steady state operation of at point 5. So it draws more current. Once the machine starts spinning and draws more current, we will, in the 5-point operation, we will reach the point 5. Okay? So the back EMF increase as the speed increase, external resistance is added using 5-point starter. The supply is connected, handles start moving, travels between point 1 till 5 until removing all this additional resistance. Since field windings are excited, the electromagnet will keep the handle at point 5, still disconnecting the source, till disconnecting the source. So it will maintain at steady state operation, it will maintain at point 5. This is the 5-point starter. But now, Osama, is this a good thing to use in real life, the 5-point starter? No, we don't like it. كل adding resistors is something conventional, traditional. Now we use power electronics. So this is a not required example. It's a very long example. He goes all over the 5 points, waste of time. So have a look at it. Let's talk about the 4-quadrant control of DC motor, with what we call it Class E. Are we familiar with Class E? What classes we had for an induction? Do you remember? A, B, C, D. We did not have E. So Class E is reserved for motors that are DC that work at the 4-quadrant of operation. Keep in mind, in induction machines, we don't have 4 quadrants of operation. We had 3 motoring modes, 3 modes of operation. But for DC machines, we have 4 modes of operation. Let's look at the modes of operation. This is the most important curve. It's very important. Focus within it. When you look at a curve, always start with the axis and ask yourself, why do I have those axes? Here I have VA. Let me think. Why did he call it VA? Why he didn't call it VT? He called it VA because it's EA. But that's another notation. So you, as smart engineers, you would know that this is the armature voltage. And what's the formula of armature voltage? The K phi times omega. So it's proportional to omega. So if I increase VA, I increase omega. You have a proof. You increase VEA, or in this figure it's called EA. You can call it EA. Doesn't matter. What is the x-axis? It's the torque if I'm going to do omega, or IA if I'm going to do VA. Do you remember the formula of the torque? Torque would equal to K flux IA. So if I increase IA, I increase the torque. So what are the combinations? I have either both of them are positive, speed and torque, or voltage and current. So this is quadrant 1. This is the typical forward motoring. Or I have both of them are negative. Quadrant 3. This is quadrant 1, quadrant 2, quadrant 3, and this is IV. So this is the reverse motoring. If I change both, torque is negative, speed is negative, that's a motoring but in the reverse direction. The challenging part is quadrant 2 and quadrant 4. So this is the regenerative braking of quadrant 1. This is the regenerative braking. We call it reverse regenerative braking. Or this is the generator motor for this is the generator motor for that. What's the common thing about quadrant 2 and 3 is you get one voltage that's positive, the current is negative. Or you get, for example, the speed is negative, the torque is positive. Or here, the torque is negative, the speed is positive. So from mechanical perspective, you look at torque and omega. From electrical perspective, for class E motors, you look at voltage and current. This is very important in the test. You're gonna ask questions about. How does it work? Well, how does it work? Using power electronics. What is the name of this diode that's next to the MOSFET?
Normal diode.
No, it's anti-parallel diode.
Okay.
Its purpose is to allow the current to flow from the source to the drain. This is the gate. So that the D3 would ensure current is flowing this way. What's the purpose of the MOSFET?
Control.
It controls and ensures the current flowing from drain to source. So now we have a two-way of controlling the flow of current. If both of them are off, no current is flowing. Okay? In this motor, how do I have EA to be positive? Plus minus, I have to make sure that this node is connected to the positive and this node to be connected to the negative. So to get VEA to be positive, I have to have the current flowing across this loop. And I have to make sure that the current goes through this direction, positive, from positive of the battery to the negative. So this requires having S1 and S4 to be on. Clear? It's logical. صح ولا لا?
Yes.
If I have the supply, positive voltage, positive current, I have to have S1 and MOSFET open, S4 open. لأن أنا قلت لكم to get the MOSFET on, it will move from drain to source. To get it diode on, it moves the opposite. So for quadrant 1, we have supply connected S1 and S4 on. So this is if I want my motor to be on. But let me to ask you one question. Do you remember this curve? So I said this is on, this is off. So in power electronics, sometimes in order to control the speed of the motor, I have to change alpha for DC chopper. To change alpha, I have to make the motor on and off. On and off. But how to make it off if I want to have alpha that's 1/12 to control the speed? أعيد هي شوي صعبة. سامة, please focus. لما يصير عندي low speed, do I want to have alpha big or small? Alpha small. So alpha is small, it means the 1/12, for example, has to be on only here. But in the motoring mode, I also have some instance where the motor has no power, short circuit. How do I make short circuit? It's very easy. To make short circuit, I have to connect this leg to the negative supply, this leg to the negative supply, and I have my motor short circuited. So to have a motor short circuited, what does it mean? It means both terminals are connected to the negative. So what does this require?
S2 on.
S4 is on, and the diode T is on. So the current was moving this direction, circulating current. D2 is on, S4 is on. Because it still requires positive current. That's how we came up with this quadrant. Why do I need it on and off this side? Why do I need the motor on and off? For a DC chopper. Why? To control speed. So if I want to control the speed, what will happen? During the off moments أرسل pulses على S2 no, I don't send pulses to S2. I make this off. This voltage will be naturally higher, then diode 2 will be on. The diode, can you control the diode?
No.
No. It's by itself will be on. So the formula sheet, you can have this figure in the exam. Okay? Next lecture we will continue the other three quadrants. But keep in mind, never ever keep S1 and S4 on, because if you keep it on, what will happen? You will reach rated speed, the maximum in your omega base. Remember, we're not playing with the fields. Here we're doing constant torque still. Okay? Any other question?
وش محتوى الفيك quiz؟
So that's a good question. What do you want the fake quiz? We finished the more induction. We had 2 quizzes for induction, so.
Maybe one.
So for induction we had 2 quizzes or 1. 2. We had 2, and then an MCQ. We had one V over F control.
Oh.
So we'll make it DC. So the fake quiz will be from example 1 until example 3. Okay? Okay? Study either, the quiz will be either example 1 or example 2 or example 3. Okay? So can you post it in the group now, please? I don't want to put an announcement. عندك الواتساب جروب؟ ايه. بس حط voice note. اكتب. It doesn't matter. يلا. I don't want to. كلها فردت. خلاص حطيتها في الجروب؟
لا واحد. ادور الجروب.
Anybody else can post it in the group. The quiz will be either example 1 or example 2 or example 3. The fake quiz.
Example 1 or 2 or 3?
One of them. To come. Clear? حاضر يبلغ الغاية. I'll try to put announcements officially, but too many announcements is too much. Okay? Not gonna ask you about example 4 or 5 or 6. It's later. But the real quiz next week, the one on Sunday, it will be
comprehensive.
no,
DC?
no, it will be DC, but all the DC until
until
Thursday's lecture. Okay?
Oh.
So this way, when you study for the quiz, you cover DC, and it will be inshallah easy. Most likely, it will be from the examples after. Most likely, maybe example 7 or 8. Okay? Or 9. Yeah, you can leave, please. Okay? شغال